Module 4 for geometry. So this is a geometry video, and we're working on lesson 4.3, proving lines are parallel. So hopefully you have an idea what that means already. You're ringing off some bells because hopefully you've seen parallel lines when you work with graphing and just kind of in general, right? So let's get started. All right, we're going to hang out over here today. Make sure, guys, as we do these, like always, you're letting me know what feedback you have, what questions you have, and I am going to work on condensing these a little bit. That was some feedback. I'll be honest, it's just a little hard because the book's kind of long, but let's do what we do. So, proving lines are parallel. The big idea today is, can you prove, or how can you prove, that two lines are parallel? So keep that in mind as we get through this lesson. So we're going to explore, we're going to write converses of parallel line theorems. So you form the converse. So if you don't know what converse is, you should probably look it up. It's not the shoe. It's not the shoe. So you do that by, if a traditional if-then statement, if P then Q, you swap it. So if Q then P. It's kind of like the opposite. The converses of the postulate and theorems you have learned about lines cut by a transversal are true statements. We talked about transversals, so if you're a little iffy, go back to 4.1, 4.2, and then come back. We're going to write specific cases of each of the converses. So the diagram shows two lines cut by a transversal T. There's your two lines, L and M. There's your transversal T. Use the diagram and the given statements in step A through D. We're going to complete the statements. Now, I will say, guys, the best way to get comfortable with this is to do it. Make this diagram multiple times. Put different numbers, different letters, and just check. For me, I have a little cheat sheet up. I found this on Google. There's a bunch of them. Make your own. And this just helps me quickly identify things as a reference. So you can get yourself one of these as well. So statements L and M are parallel. So if that's true, then we know that angle 4 is congruent to angle 6. Angle 6 and angle 3 are supplementary. So that means, let's use a different color. Angle 6 and angle 3 are supplementary. So that means angle 3 is congruent to angle 7. So we're taking all the different relationships that we're building and using them to find relationships with other angles, finding the different angle pairs. Alright, let's keep it pushing. So use two of the given statements together to complete a statement about the diagram using the same side interior angles postulate. Again, guys, if you have not made a good cheat sheet based off of the last couple lessons, that's where you want to be right now. You want to pause this video and go back and get a good cheat sheet of all your notes, because this is a lot to juggle, and your brain's probably going to struggle. So by the postulate, if lines L and M are parallel, takes me longer to write on this, then angle 6 and angle 3 are supplementary. Right? What does supplementary mean again? Exactly. They add up to 180 degrees. Yep. So now write the converse. So this is our first exploration. So instead of going if the lines, then the angles, we're going to go if the angles, then the lines. So if angle 6 and angle 3 are sup, I'm going to start abbreviating so I don't kill you out with my handwriting. Then lines L and M are parallel. So go this way, go that way. Same deal. So we're going to continue. We're going to repeat that to illustrate the alternate interior angles theorem. So again, find that note sheet. And it's converse using the diagram and the given statements. Again, guys, geometry is very wordy. It's easy to get lost. It's not like algebra where you can kind of just figure it out. You got to make sure you're keeping tabs on everything. So please hear me when I say that. Get yourself organized. Get yourself some notes. That's one of the reasons why I struggle sometimes doing geometry without spending the time to figure it out, because my brain's more of an algebraic, let me just figure it out brain. It's just how it is. And it's okay if you are like that too. So by the theorem, if lines L plus M, that's and, not plus M. I should have put an and there, but I'm trying to fit. Then angle 4 and angle 6 are congruent. By its converse, if, yep, angles 4 is congruent, put the wrong symbol there. If angle 4 is congruent to angle 6, then we know the lines L and M are parallel. So keep that in mind, guys. It's just going one way, going the other way. We can do that using converses. Alright, now corresponding angles. So again, if you're like, ooh, what are these things? Well, you know, this can be a quick little cheat sheet to help you remember a couple things. So like alternate interior, 4 and 5, etc. But make sure that you are using your own. You have your own. So by the theorem, if the lines L and M are parallel, so think about what a corresponding angle could be. Then angle 3 is congruent to 7, and again, you go up here, take a look, you can figure all this out. By its converse, if angle 3 is congruent to angle 7, then the lines are parallel. I'm not going to write that because I'm getting tired of writing the similar thing over and over. So again, guys, pause, clean this up, write it down. If you have questions, jot them down, make sure you send them my way. Let's keep it going. Alright, so how do you form the converse of a statement? You're basically reversing the hypothesis and conclusion, right? So if it's if P then Q, it's if Q then P. Simple. What kind of angles are angles 4 and angle 6 in step C? What does the converse you wrote in step C mean? So there's step C. So let's take a look at angles 4 and angle 6. They are alternate interior angles. And if they are congruent, then that means that the lines are parallel, L and M. Bada boom, bada bang. I don't know why I've been saying that lately. I have no idea where that came from. Don't let me say that anymore. It's weird. Alright, explain 1. So again, I try to chunk it out. Explain 1. So if you need a breather, take a breather. So proving that two lines are parallel, the converses can be stated formally as a postulate in 2 theorems. So I would get these into my notes. You got 3 converse, 1 postulate, 2 theorems. If 2 lines are cut by a transversal, so that a pair of same-side interior angles are supplementary, then the lines are parallel. You notice then the lines are parallel, then the lines are parallel. These are all to help you prove if the lines are parallel, which is the essential question today. And parallel lines, you know, they never touch. They're equidistant at every point. So sadly, this is you, and this is your soulmate. And that means that you will be heartbroken. Sorry. Alright, so you can use these converses to decide whether 2 lines are parallel. A mosaic designer, this is just weird, but whatever, is using quadrilateral shaped colored tiles to make an ornamental design. Each tile is congruent to the one shown here. That's my beef with math books, is that they just give lame examples. And it's hard sometimes. Trust me, I try to make my own. But whatever. So, there you go. You got your line 1 and 2. You got line 1 and 2. You got a 1 and 2 marked as angles. So we know the lines are parallel. That's a given. It's important to make sure we know what's given. We know the measure of angle 1. We know the measure of angle 2. You should already be seeing boom, boom. That's 180. You know they're going to be supplementary. So then you can say that by the converse, so knowing that they're parallel, you can determine that these are same-side interior angles. So you're using the lines, you're using the angles, the measures to prove this. So you can say that line 1 is parallel line 2 by the converse of the same side interior angles postulate, and that's up there. So basically, make sure you can determine, yeah, if these 2 angles and they're the same side interior, if they're supplementary and they're interior angles, then that means that these lines have to be parallel. Alright, we got a new situation. You may want to pause and try this on your own. I highly recommend that. Do that, please. So measure of angle 1, definitely not acute. Obtuse rubber goose. This is also not acute. They are the same. Now you could measure it, right? If you had a protractor. That's why this is a little weird right now. Relationship between the 2 angles. Well, are they same side interior, or what are they? They are congruent corresponding angles. That might be a little bright for your eyeballs, I'm sorry. Corresponding, congruent corresponding. So we could say that line 1 is parallel to line 2 by the corresponding angles theorem. It seems pretty simple, right? I hope it does. What if, suppose the designer had been working with this basic shape instead? Do you think the conclusions would be different? Why or not? Let yourself some time to do this. Remember, hit that pause button, guys. Hit that pause button. No, right? It wouldn't be, because you still have the congruent corresponding angles and supplementary angle pairs. So just the numbers change. No hoopla there. Your turn. Let's take a look at 5 together. Explain why the lines are parallel given the angle shown. Assume that all tile patterns using basic shape. You're given the information. So angle 1, angle 2, angle 1 measures to 120, angle 2 measures to 60 degrees. Are these angles supplementary? Yes. Why do I keep clicking that color? The lines are parallel due to the converse of the same side interior angles postulate. For this one, I might as well give it to you. These are both 120, right? Alternate interior angles is where you want to go with that one. Whew, breather, explain 2. So, constructing parallel lines. The parallel postulate guarantees that for any line L, you can always construct a parallel line through a point that is not on the line. So, we're not going to like fully do this, but it is important to know this, that every line has a line parallel to it. So if you had a compass and straight edge, this is how you would do it. So if you have these tools, go for it. You know, a cheat sheet way would be just to draw a straight line, take a ruler, take a straight edge, come off of it somewhat, draw a point, and then slide your ruler down. But you would want to do it, you know, precisely. So there are some digital tools that if we ever need that for something, we'll come back to it. But right now, we're just going to rock with it, okay? So the parallel postulate is used in the construction because it guarantees, you know, that you can always construct the parallel line. And why must they be parallel? That is a question that does matter. So congruent corresponding angles were constructed. So the converse of the corresponding angles theorem applies. So it comes back to those theorems. So if you have the space, go for it. We're going to keep it pushing. Keep pushing, keep pushing. So explain 3. Look at that. Shortcut. Some questions that we might want to just be considering at this point is, what are some congruent angle pairs that can be used to prove 2 lines parallel? You can use corresponding angles or alternate interior angles, so that I would just jot those down as notes. And what are some angle pairs that must be supplementary to prove 2 lines parallel? Same side interior angles. Alright, using angle pair relationships to verify lines are parallel. So that's all this is about, guys, is rocking with these angle pairs. When the 2 lines are cut by a transversal, you can use relationships of pairs of angles to decide if the lines are parallel. So, in the example, here's our diagram. We're saying that angle 3 is congruent to angle 5. Now, right away, I know that's alternate interior angles. Identify the relationship. Boom. Congruent alternate interior angles. Look at that. The book just read my mind. Are the lines parallel? Yes. And you don't have to go through any proving and doing all this crazy stuff and wondering and writing a bunch of words, because you know that you can use the converse of the interior angles theorem, because you have the congruent alternate interior angles. And that's what's cool about theorems, is that once you know the generalization, you can just apply it to your situations. You don't have to keep on proving it and proving it and proving it unless we want you to prove it. So here's an example with some math. So we're pulling out some algebra here, just so you're aware. We know the measure of angle 4, we know the measure of angle 8, and we know x. So first, identify the relationship between the 2 angles. Well, angle 4 is here, and angle 8 is here. Let you pause, because I know you might not have paused. Pause and do this, please. And then let's check it. So we know right away that we can plug in for x, right? Substitution. So this is going to be 15. That's going to be 35. That's going to be 30. 35. Look at that. They're congruent. So we can say that angle 4 and angle 8 are... Why do I keep putting that under there? Like I'm teaching inequalities. I am soon in algebra, but not yet. Speaking of which, if you're struggling with this algebra stuff, basic stuff, I got plenty of videos, guys. Go watch them. They're congruent corresponding. Congruent corresponding. Congruent reminds me of Gru from Despicable Me. Congruent corresponding. And are they parallel? Yes. Converse of the corresponding angles theorem. So again, pull up your cheat sheet if you have one. Boom, boom. Look at that. Corresponding angles. Your turn. Try these on your own, please, but I will drop some knowledge. So I'm looking at angle 3. I'm looking at angle 6. Look at that. Same side interior angles, right? You know they're supplementary. Same side interior angles. 2 and 6. 2, 6. Congruent corresponding. Are they parallel? Yes, by the converse of the corresponding angle theorem. We're rolling. All right. Try to push yourself on these guys. Even if it's not, if you don't really know what you're saying completely, like it's good to practice writing because writing helps you remember. How are the converses in this lesson different from the postulate theorems in the previous lesson? So previously we knew the lines were parallel and things about angles, and now we know the things about the angles and that the lines are parallel. So it's just the order in which we're proving things. You know, a common error that you might see when you're working with the converses is that you're assuming that the lines are already parallel. You can't just assume that automatically. You got to prove it with the angle pairs. So establish that there are those congruent angle pairs, the corresponding or the alternate interior, or that they have the same side interior angles that are supplementary. Because if you say that there's parallel without checking, you're wrong. You got to prove one of those cases. So that's a note. Write that down. Rewind. 10 seconds. What if, so 2 lines cut by transversal, such that alternate interior angles are both congruent and supplementary. Describe the lines. Well, you would have to construct this so to be supplementary. So 2 lines cut by transversal. If they're congruent and supplementary, we know the lines are parallel, and all the angles would be, so this is a bad diagram, all the angles would have to be 90 if they're going to be congruent and supplementary, because 90 plus 90 equals 180, so therefore the diagram would look like that. The transversal would be perpendicular. Name 2 ways to test if a pair of lines is parallel using the interior angles formed by a transversal. So again, lots of vocab, guys. Make sure you understand the vocab. So you could measure the pairs, you could use the given information, decide if they are congruent or if the same side interior angles are supplementary. So, summary, what are the angle relationships that would prove they're parallel? Write this down. A pair of congruent corresponding angles, a pair of congruent alternate interior angles, and a pair of same side interior angles that are supplementary. So, 3 cases, write those down. That's how you prove things are parallel. Get some practice in. You know, these are pretty straightforward. Anything with this diagram, guys, the parallel lines, transversal, you want to be doing as much as you can. It's going to help you stick. Boom. Hit that. Maybe do one of these. You know, some application with some algebra is always good. You don't got to do the construction unless you want to. This is good, 2-column proof. Maybe do one of those or both. And then, you know, that's there too. So let's go back to the top. Let's answer our question. Did we answer our question? So hopefully, guys, this lesson should be pretty smooth if you understand 4.1 and 4.2. Like I said, if you don't, go back to the videos that I have and watch them. If you know the angle pairs, the angle relationships, you should be straight. So how can you prove that 2 lines are parallel? Hopefully you can answer that. So pause and write down what you think it is. Summarize your notes. But an answer could be, you know, looking at the angles formed when a transversal crosses the 2 lines. If you have a pair of alternate interior angles that are congruent, a pair of corresponding angles that are congruent, or a pair of same side interior angles that are supplementary, then the lines are parallel. So hopefully this was smooth. This is a slightly shorter video, 20 minutes. So pat on my back. Notice the holiday Christmas tree. We out here, December. I should have worn my hat, one of my hats. I got lots of hats. I'll wear one next time. But that's all, guys. So again, 4.1, 4.2, 4.3. I'm coming with the rest of them soon, and you're getting ready for your Module 4 quiz. Semester 1's rolling, guys. So that's all I got. It's Mr. Hansen at Mr. Hansen 414. Do yourself, do one of your friends a holiday favor and send this to them so they can subscribe to me and get some help. Because I'm sure that there's a lot of friends that have geometry and algebra needs. So thanks for watching, guys.